Okay? It's what keeps creation doubling. What are examples of doubling? We could take cell division. Okay? You can see you have one cell, which becomes 2, 4, 8, 16, 32 cells. They stay all together as an aggregate until they reach 64. At 64, all the cells become individualized. They can become brain cells or heart cells, right? So at 64, you get each cell becoming an individual. In other words, showing the parallel between the 64 and the 1. Okay, this is why 64 is a cycle in the Mayan calendar or in the I Ching, all relating back to the 1. It's a completion of this cycle, which we call a bounded infinity. It's an infinity of duration, constantly moving, not necessarily an infinity of direction, because it has an axis, which we're going to talk about. Okay, what else doubles? How about music scales? From C to C to C is doubling. Okay, doubling harmonics. You go from 440 to 880, or depending how you're setting your frequencies. You have doubling in harmonics. Okay, so there's many examples of these numbers of doubling and how that works in creation. Take, for instance, nuclear reactions. You have one neutrino, which liberates 2, which liberates 4, which liberates 8. In other words, neutrinos are working on a doubling sequence as well. Sometimes it's called a chain reaction or a geometric progression. Another example of doubling, the binary code in computers. Okay, I can go on. We could talk about the 64 codons in the DNA. All of this highly related. Okay, but let me continue with our basic number sequence. What happens if I follow my track in the opposite way? Well, if I'm doubling this way, I must be halving in the other way. So let's find out if that's true. Half of 1 is 0.5. Again, back to my 5. Half of 0.5 is 0.25. 2 and 5 equals 7. Half of 0.25 is 0.125, which equals 8. Half of 0.125 is 0.0625, which reduces back to 4. Okay? Halving works the same way. I can't remember what half of 0.0625 I think is I forget what the number is. Anyway, you can do it. You can make the calculation on your own. You'll find no matter how far you go, you can half. I could do it just as well. I could say half of 10 is 5. Okay? Half of 5 is 2.5, which equals 7. Okay? So you can do it any number of ways, and it's always going to work. This is an infinite series of halving. Very significant. Okay? Because when you have a motion in one way, you're going to have a trailing motion in another way, and we're going to talk a lot about that and how it works. This black line that you're seeing here is the pathway that everything takes that moves in creation. It is the spin continuum that the universe is on. It's why the universe is always moving, but it's never actually going anywhere. It's on a treadmill. It's a bounded infinity. All right, and you're going to get real familiar with that concept of the bounded infinity. It touches everything we're going to do. But I don't want to get too stuck on that. I want to take a look at some of the other properties of my symbol. Now here I've talked about 6 numbers. 1, 2, 4, 8, 7, 5. Back to 1. What about these numbers? Now I have 6 and 3 and 9, and they're connected by this pyramid. It's only connected at the top, by the way, never connected on the bottom. So this triangle or pyramid here connecting the 3, 9, and 6. Well, let's find out what happens with these numbers when they start getting mathematical functions. Let's take 3 at first, since it's the smallest, the simplest. What happens when I double 3? 3 doubled becomes 6. Okay. Well, 6 doubled then becomes 12. and 2 plus 1 is 3. 12 doubled becomes 24. 2 plus 4 is 6. 24 doubled is 48. 4 plus 8 is 12, and 2 plus 1 is 3. 48 doubled is 96, which comes back to 6. Okay? So no matter how far you double these, you're oscillating, 3, 6, 3, 6. Halving would be the same. I could say half of 6 is 3. Half of 3 is 1.5, which is 6. You could do it any number of ways. Half of 30 is 15, which is 6. No matter which way you do it, halving or doubling, 3 and 6 are oscillating back and forth. None of these numbers do that. Before you can get to another 1 on this doubling path, you've got to come all the way through these other numbers. Only 3 and 6 are oscillating back and forth, just like magnetic fields, okay? Like a pulse, like a representation of duality, of opposites, in and out, to and fro, back and forth. Okay, that is how the 3 and 6 work. We could call them and refer to them as magnetic numbers. But how come if they're oscillating back and forth, they're not connected to each other by a line? You see there's no line here. And in fact, my 6 has to go up here before it can come back down here, and the same with my 3. They're both connected to the 9. Now I've hesitated to get to the 9, but in fact, it's the most important number. Or we shouldn't say that. Maybe we should say all the numbers are equally important, but the 9 is really the king of the system, or the queen of the chess game. It is the control for everything else. So what is the 9? Well, what happens if you double 9? 9 doubled becomes 18, right? 18 doubled is 36. 36 doubled is 72. So if you add any of those numbers together, 18, 36, 72, they always equal 9. What about if I half 9? Half of 9 is 4.5, which equals 9. Okay, half of 4.5 is 2.25, which equals 9. 5 plus 2 is 7, 7 plus 2 is 9. So no matter whether I double or half, the 9 is never changing. It's forming an axis here that's polarizing all of these numbers. Because in this system, we're actually able to give polarity to numbers. So I've shown you one function here. We've been talking about, or two functions you could say. We've been talking about doubling. We've been talking about halving. But let's go back a little bit simpler. Let's try to understand, before we go too complex into physics, what are these numbers and what do we mean by the functions of math? Okay, so we'll start simply with multiplication tables. All right, let me bring up my next board. Okay, now here I don't have my lines drawn in. I'm sorry for the primitive board, but you'll have to bear with me. Here I'm showing you multiplication tables. Now we started with my 1. Okay, the number 1, when you multiply it, what does it do? 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 5, 6, 7, 8, 9. After that, I'm simply going to repeat. If I go to 10, 1 plus 0 comes back to 1. 11, back to 2. 12, 3. 13, 4. 14, 5. So no matter how far I multiply, when reducing to single digits, I'm constantly going to have this pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the only number that will make that pattern. 1 is the only multiplication series which goes up in increments of 1. So it's unique. One of the important things in the system to remember is that there's never any redundancy. It's never doing the same thing over and over, or the same thing twice, you could say. Exactly. So 1 is the only number which goes up in increments of 1.